welcome to today's episode of Conscious Design Podcast. Today with me is Peter, polymer engineering lead from Carbon Upcycling, based in Calgary, Alberta. They're a interesting company with working on how to use all the carbon that we've been putting out for a long time. Welcome to the show.
Thank you for having me, and it's a pleasure to be here.
Yeah, so tell us a little bit about what is your process? What do you do? What do you capture? Obviously carbon, but kind of what is your technology that makes what you're doing unique?
hmm I like to open with maybe just taking a few step backs and talk about why we got started as a company. I think that shapes
Perfect.
itself quite well. So, Carbon Upcycling is a startup organization based in Calgary, Alberta, Canada. We're about a team of 7 full-time employees and been around for about 7 years, with really the vision of transforming the waste of today into sustainable materials for the future. And it's that statement that got us thinking, uh, almost like the modern day garbage man of like, what is the things that people don't want the most, and that we could aim to repurpose them and find a new home. And of course, at the genesis of the company, it started with CO2, the massive problem, which now I think we're seeing ever so increasing impact of climate change and the increasing amount of CO2 in our atmospheres, such as like the recent floods in the BC area. So what our process and why we're so different as a company is that we devised our core patented technology, which allows us to very efficiently utilize carbon dioxide. And so what we do is we take two industrial wastes. So one would be different types of industrial waste in the form of a powder. And then the second being the gaseous CO2 that otherwise would have been emitted to the atmosphere. And instead of using them in conventional storage methods, for example, injecting them deep underneath the earth in aquifers or in salt domes and stably kind of storing them, we utilize it. And we stably transform this into a additive product, which, I like to say we sell powders as a company, but it's a performance additive that not only decrease the use of carbon intensive materials at the end application, but also has directly sequestered CO2. And so it's when we think about the end application that really differentiates our company against some of the other groups in the space. So there are groups that converts carbon dioxide into fuels and transforming the sustainable aviation industry into different types of plastics and chemicals. And we primarily started our key focus in the concrete and construction sector. And so our enhanced fly ash additives, what we call, is a product that allows a double-digit reduction in the use of cement, which per kilogram of cement produced, you emit 1 kilogram of CO2. And not only that,
it's a terrible material.
But I mean, we've been using it since like forever. The columseums are built from it, and there's
Right.
ever going to be more and more cement demanded as we aim to rapidly urbanize, the entire world. And, as building degrades, and for example, I think there's actually a renovation infrastructure regulation or bill passed in the EU about renovating. And so, you're going to have to use more building materials there. So it's really, we haven't found a good alternative to cement. And so,
Right.
The pathway that we've been proposing is like, okay, we still have to use it. So let's see what we could displace out. And so what we've done now with our tech is actually shown that not only you're realizing double-digit reduction in cement, but also you're getting up to anywhere from 20 to about 50% increase in performance in the form of mechanical properties. And so what that means, you could build stronger buildings, you could reduce possibly the aggregates and or cements you're using, and overall create a more wholesome product that has a lower carbon overall life cycle carbon emission product. And so that's kind of one area. And of course, my role is to kind of replicate that same a value proposition, and to introduce some of our high performance plastic additive to replicate the same thing, creating more sustainable plastics, encouraging the use of more and more post-consumer recycled materials, and enabling the creation of thinner wall parts. So we're using less virgin materials.
Mm. So you're because of your additive, you're able to increase the strength of the material basically and allow less less overall material to be used in general, but also replacing some of that virgin material with your additive, which means you're using even less plastics.
That's right. And in some scenarios, we can actually, like, the amount of captured carbon dioxide onto your end product, like let's say for a pen, for example, is pretty significant. So like we this year we developed a product, a natural rubber yoga mat, where we're embedding about 40% of our talc additive, which is kind of a white powder readily used in the plastics industry. And now, because of that displacement, we've actually encapsulate anywhere about 7 to 8% of CO2, carbon dioxide, that otherwise would have been emitted to the atmosphere directly onto the mat. So it's kind of exciting where, on one perspective, you're displacing the carbon intensive materials, but the more you do it, the more actually the directly captured materials also goes into the end product.
Got it. And to kind of jumping back to your process, when you're starting how you get to your material, you're taking two ways. So your focus is really in working on existing factories. Say you have your whatever production plant, you're able to collect straight from the pollution source, basically, rather than trying to wait for it to go somewhere else. You're capturing it immediately and then being able to process that into some other usable product. Is that was I following that right?
Yeah, it's surprisingly in the plastic space, that picture is much more complicated. But
Okay.
that is what we're doing as a group. We're looking to tie in our technologies into strategically placed geographies that were located,
Mm,
co-located with the waste streams, right? Because also one of the biggest impact we found is, how much more transportation would add to the end product, and how much worse
right.
transport additional steps of transportation makes your product worse in terms of the life cycle impact. So what we do is, our technology is sort of like a small plant, if you will. It's a reactor, and it occupies a certain footage of area, and we don't use any water. And what we like to do is actually
Mm,
tie that downstream of a plant. So for example, on our construction materials plant, we look at the integration of our technology into pre-existing cement plant or batch mixing plants. In either cases, those are the materials that ultimately could potentially go into a ready mix truck, one of those rolling cement trucks on the road. And
right.
so we're a step that proceeds before that. And that's how the materials gets integrated. So that way, we could look at integrating some of the waste on site, for example, the CO2 emitted from the creation of cement. Sometimes facilities do have an integrated unit like that. And otherwise, finding those key geographic waste sources, either immediately downstream or close to, so that way everything could kind of be tied all together, versus like what you mentioned, like, you're multiple steps removed from it. We like to be as close to the existing steps without introducing too many processing steps as possible.
Right.
However, on the plastic side, it's a little bit more complicated. I'm not sure if I like to think like the modern day consumer has a good understanding of plastics, but I learned the other day, like, even we look at our technical ski jackets, right? There's about parts that comes from roughly about 100 to 200 different suppliers that came all together that made that jacket. And so that just kind of sort of goes to show how, messed up and probably distributed the supply chain is. And that's
Mhm.
sort of where the complication comes in. And so for some of our work, even on the industrial side, is um, we create our additive, we sell our additive to a compounder, which mixes them into a carrier resin. You could think of it like a juice concentrate. That's the way to efficiently introduce your material. You're buying concentrate, you letting it down into water to get orange juice. So think of like our material as like we create the orange juice concentrate, and then we sell it to our customers in the injection molding world, which then lets it down and create the final product with the specification, with the right type of material blends. And that's a very idealistic world. And oftentimes there's additional processes along the way. Sometimes there's some transport across the world. And even in projects we embark on in the cosmetic world, there's the filling of the cosmetic, which you have your package that now goes somewhere else in the world possibly. And so it's really, really involved from start to finish.
Right. Well, that's a good point. The transportation of the material, right? If you make a super green alternative, but you undo it all by how much you have to transport it to someone, then it kind of ends up not being what you were hoping for in the end. It's not producing the actual result that you wanted to do. So it's good to see you guys are thinking about it and thinking through that as well, of just being aware of, okay, yeah, let's think about transportation and how do we not drive it around so much that the truck puts off more CO2 than we just saved.
Right. And surprisingly, it's a much harder problem, right? Because we look at the global supply chain. I think for concrete and construction's okay because it's local, right? Like, you always have local projects and vendors and local subsidiaries of large multinationals. But then you look at plastics, which, it's been heavily commoditized. Oftentimes, a lot of production's been sourced overseas. And then from one perspective is interesting because we now have to look at exporting our technology, to tie it down there. So we're not shipping powder from Calgary to Asia and then to only ship the part back to Calgary.
Right. Nobody wants that.
Yeah, right. So it's kind of interesting. And of course, with like the political dynamics of how automation is going, and folks are actually taking manufacturing back to North America, and so there's a bit to consider there, but it's a complicated game.
Right. And yeah, we talked a little bit, part of your role is helping with the application, right? Because you have this core technology of we can collect CO2 and make it useful. Now you guys partner with companies almost and help produce kind of a custom product almost for each application. Is there any areas where you haven't been able to use it? Is there like any limit you found to what CO2 is possible, or is it so far been, like, well, we can always there's always something to do with it because it's so useful?
Yeah, I think this is really where we're limited by our imaginations. I think this year alone we've done about 16 very distinctive product applications. I would like to say, the one limitation we've definitely seen is color limitations, because our flagship product is a black powder. So forget about any kind of like RGB you got. If you want something blue, it doesn't work. But what we're developing now is also a white additive. So then it does allow you to still work with a blank canvas and to apply the appropriate kind of color alterations to realize that. So from a chromatography kind of a perspective, there's some limits. But in terms of the application itself, like I think we've done tremendous work. Like I mentioned before, we've done a lot of work in concrete, both industrial and consumer. We've done quite a bit of work on construction materials for plastics, rigid packaging, flexible packaging in the form of different types of films for various applications. really neat industrial parts, where it actually demands the performance aspects. Um, Rubber yoga mats, rubber tires. We've used our materials in paints, pigments, and dyes. So creating
Mm.
different type of artistic product, which you can actually find some of them on our consumer facing page, expeditionair.today, where we've launched a artist in residence program about a year and a half ago, I think, give or take, where we've now working with the artists and our chemists developed bespoke solutions such as oil-based paint, water-based paints, and just
Mm.
give them, here's a portfolio of carbon capture materials. Where could you see it being used? And some of them got really creative, like creating crayons with our materials, different types
Those
of
are nice.
um, inverted color paintings using the black. um, and
Yeah.
and like they even made dyes for screen printing on t-shirts, which is an area we're collaborating uh, with a few large brands on, because it's really simple, right? You could simply um, you know partially or fully substitute the pigments you're using today just to see how it performs. And in most case scenarios, we found that it performed just as well. And here's a healthy low carbon solution that was derived from waste that you could use in an existing application. So there's quite a range full. And of course, like, there's also the other extreme where we've been looking for the past, at least I'd say, like 3 to 4 years, looking at even the use of our materials in pharmaceutical applications, in as a drug delivery carrier, recognizing that different types of
Interesting.
nanomaterials of different shapes, dimensions, and chemistry have a good and or bad impact on cell viability, or how fast or quick cells dies. And so even exploring how graphitic or carbon capture materials could be used in modern day drug delivery. So it's really quite a range, and we try to really
That
push
is.
it out there.
Which is awesome. I mean, everything from pharmaceuticals to construction to pigments. I mean, you're you're kind of covering the bases on that. Have
All
you?
sectors of the S&P.
Yes, yes,
A-
yeah. You're
and I think like that, I mean, it shows sort of maybe perhaps our resourceful approach, but I think, you know, uh, the problem becomes like there's definitely more than enough CO2 to go around for everyone. And
yeah.
and
We've
of
been putting
course,
out plenty.
and like to be like in the IPCC report, like it's very clear from several years ago that to be carbon negative, you don't get away, you can't get to where we need to get to simply by planting trees. Like there's already enough in circulation, right? So,
Right,
and
right.
even if we had all the land, which is another consideration on sustainability, like
Mm.
you can't put enough trees out there, so you need actually utilization processes to do that, right? And there's different methods and approach, and it's there's no one solution that fits the puzzle, and we're just trying to make this versatile and accessible, and sort of in a way almost like democratizing carbon utilization solutions for everyone, and making them accessible so that people could try and play and realize that there's an affordable or a fit of a solution for them that they could play around and experiment and ultimately use in a way they feel that it's impactful.
Right. Well, I think that that's part of it, right? Is just showing people it's possible, right?
Hmm.
And it's one thing to be like, oh, carbon's great, and we use it in lots of things, and we also spew it into the air. And it's a different thing to say, oh, well, we've captured some of that and we've turned it into a product that you can use, and now you're painting with with it right now. Here you go. Have some colors. Here you go. It works.
Exactly.
So
Yeah.
it's that shift, which is great that you get. That's what you guys are working on, is showing we can do this. We can apply it to all these different areas, and I like your point too. There's plenty of CO2 to go around. Like we can capture it. It's not you're not going to use all that we're producing anytime soon by yourself. So it's
Mhm.
something long term that we should be utilizing,
Definitely. I mean,
right? And
there's a lot of great alternative technologies and complementary technologies. Like today we're tied downstream of the Alberta Carbon Conversion Capture Conversion Technology Center, which is next door to a large power plant. It generates about 800 megawatts of electricity, serving about a third to the city of Calgary. But
mm,
like what happens if you have a boiler at your house, right? Like, and like there's a size or scale mismatch, but I think that goes to show it's like there are technologies out there that ties it in. For example, like one of our favorite soap companies, CO2, they're also a local company. Their technology ties into a boiler, and they create what they call perlite. I think that's maybe I'm misspelling their technology, but then that gets converted into uh, bespokely crafted soaps. So it's a different way of utilizing CO2, and so it once again it kind of goes to show like the diversity of sources, where it comes from, how much, and really there's a lot of it. So
right, right.
yeah.
Oh, that's awesome. Well, what are your long term? Is there any long term we'd really like to, I don't know, make some carbon nanotubes out of this? So there's is there like a long term goal with like what you guys are trying to do besides democratizing it? Is there any areas you're really trying to push into or develop that you could share?
Mhm. Yeah, I think from a vision perspective, as a group, we're setting our target to be the most impactful carbon utilization company of the century, or rather decade.
Amazing.
Century is a little bit long, but decade, I think
You
this
never
is like
know.
but I mean, like, this decade is really going to be the turning point of how we aim to get started and transition and to reach our targets of net zero, right? But definitely some of our longer term work is that I think quite a few times we like to make ourselves obsolete and challenge our assumptions behind the work, and always striving to put a lot of R&D efforts, whether that's collaboratively with our network of university partners, or like internally, to look at new technologies. And so one of the areas I'm really excited about and quite baffled by is now, today we made an additive that helps move the dial, or at least begin the conversation on creating more sustainable performance-based composites. But then going into tomorrow is we still need to change the basic material itself, the resin, right? That makes up your pens and everything around you. And like there's lots of great work that's already going around the industry, like people making polyethylene from sustainable corn, for example. There's folks that's making nylon in comparison to the convention. They're using castor oil, which is, a more renewable source. And so there's
Mm,
chemical recycling. So we're starting to see the shift towards um, the more circular economy aspect, especially in the plastic sector, which gets scrutinized incredibly a lot. um
yes.
and like I wonder sometimes if it's almost too much, because like we recognize like, hey, microplastics is a huge challenge, but it's also an interesting opportunity to look at it. It's like, hey, like, could we start creating designs that addresses that? I think there's a lot of um I think end of life is going to be more interesting than actually start of life kind of going forward, because I think
Yeah.
in Europe they just released some more regulations on encouraging folks in the agriculture sector to use films that are biodegradable rather than the ones that are not.
Mm,
um,
mm-hmm.
but then if you look at overall how materials become sustainable is through reusing, right? I think like one of the interesting examples, like well-made leather bags that gets passed down for generations. Like you could almost say like the life cycle impact of that is almost zero because it's been extensively used so many times. And so it's
Right.
like designing highly recyclable materials that has good performance and it doesn't degrade over time and it's consistent for the recyclers all the way back to the processors. That's what we're working on as one of the high importance projects on designing highly recyclable plastics that meets function form demand today, but also going forward, and possibly even making that partially, if not fully, out of CO2. So that's something exciting
Amazing.
that's probably causing me to lose a lot of sleep and hair. Not that I had much to begin with, but really, it's I see the industry. It's almost like we're looking at two extremes, right? One was that aspect I just talked about, like highly recyclable materials, and then the other is like you want highly biodegradable materials. So you look at
Right.
garbage bags, and you throw that into your black bins that get carried away, and if that is truly non-recyclable, fully disposable garbage, you want it to degrade. And then
Right.
on the other stream, if it's very pure and it's uniform, you want it to be highly recyclable and non-contaminated and be introduced to recycle. But then here's all the stuff in the middle, which like I have a hard time grasping, right? Like, look at, for example, um, small widgets like your iPhone chargers.
Right.
Like, how do you make that? Like, I honestly don't know, but um,
Yeah, I don't know either.
like, do people? Because people would throw this out in their black bins, and so it's like,
Oh yeah,
what's the
it
right
gets
way to do that? And so like those are kind of interesting things we think about where it's like, hey, maybe there's very interesting molecular biology we can incorporate into this. For example, like using um, extremophiles, which is a type of bacteria that could handle extreme conditions, like thermophiles, as the name imply, would could tolerate up to certain heat. And so maybe the thinking is like, hey, we genetically modify these so that it's designed to break down a certain material with a certain lifespan. And each year it degrades without impacting its form. And of course, it could withstand all these harsh conditions. And by the intended design life at the end, it's a material that's almost biodegradable. It's a thought. We honestly don't know, but the stuff in the middle is, I think, what really keeps us up at night. So, one key area of focus, as mentioned before, is actually using CO2 to create highly recyclable materials. And we're really, really excited about that. And then the other one, which is like, what's happening here in the middle, and could we now actually look at different types of molecular biology techniques that were used in the past for various areas of other applications, right? Like conversions to fuels, people use microbes for that. Converting from CO2 and other types of sources and creating biodegradable plastics, they also use microbes. And so now, like looking the stuff in the middle, it's like, well, what if you don't want it to be fully biodegradable, but still somewhat recyclable with certain features? And,
right.
it's almost kind of like you're piecing Legos together, except each Lego block is from a discipline of science or engineering.
Right.
So that becomes pretty exciting. So that was a mouthful.
Well, and it's funny you mentioned like the whole longevity part too, because we also, I think we don't always think about that as much anymore either. Is like, well, what if we want that material to actually last 100 years? What if we don't? We're not as worried about, and maybe it's a triangle. Maybe it's biodegradable, recyclable, and lasts forever without damaging things. So not microplastics, but some other form, because there's also that balance of, like you said, well, the impact of that leather bag that's handed down through generations. Well, that's such a long time. Whatever impact it did have in the beginning, it's been spread out over its useful life, right? And how long
Mhm.
is something actually useful for? And I think that's something that kind of plays into this, and what you mentioned is that we got to think about that as well. Like, how long do we want it to last? How are we spreading that, whatever that impact is, right, over time?
Right.
That's part of it as well, right? If we make a huge impact all at once and then we throw it away, well, it's not very, it's not very useful.
Hmm.
Right? That's a heavy impact. Whereas a long life cycle makes that not actually as big of an impact. So I guess.
Yeah, it's a great point. Like years ago, I had this thought, and I watched like I get called out on this is completely wrong. Like I think there's several literatures that talks about like how over the life cycle EVs are actually no greater than fossil fuel burning cars. Like for
Mm,
example, ones that runs efficient because of cobalt lithium mining, and so like when you talk about like you plot it against time, it really looks like a big sharp shoot, and then like it rapidly flattens out, and all you have to do is charge it. You don't have to do too much, right? Versus a fossil fuel car might go up in like a steady ramp way. It jumps up from the manufacturer of the car, and then it ramps per kilometers of fuel you drive,
right.
which leads to fuels you burn, right? And like the duration to which emissions comes in, it's kind of an interesting one because exactly to the point you're mentioning, it's like, do you want longer but more mellowed impact or a sharper one? And this in this case, like the impact being like negative, right?
Right.
And like part of this journey has to go back to the consumers, which is why uh, Expedition Air, our consumer facing brand, got started, because there was a lot of myths or education we found ourselves had to do to
Mhm.
teach the consumers about like what's carbon, how do you use this, how do we transform this powder into something
What
useful,
what does it mean?
and yeah, and then making it tangible, but also like encouraging people. It's like you as an end consumer have the power to, ultimately everything comes down to the consumers, right? You have the power, the purchasing power, to make a decision on how you aim to leave an impact. um and it's like even to I think there's like these really interesting clothing trading upcycling programs. I think Patagonia's got one where you like donate your old clothing, and
Mm.
they try to like restitch a bunch of things together,
Oh,
and
I've
they
heard
they
about those.
resell it. um and then it's like, to a normal consumer, it's like, oh geez, like why would I want to buy used stuff?
Right.
Like I think these are like interesting questions, right? It's like, how do you know it's washed properly? I might go home and wash it again, right? and
Well,
and so
I'll
like
say
this.
I'm the person that washes all clothing I get, new or otherwise. I know what manufacturing is, so new is not as new as you think. That's so anyway, side note.
Right. And it's like I think of it in terms of, okay, so you purchase that, and what if like one day you don't like it? Then do you trade it back, and do someone like disassemble it and try to assemble another pattern with it? And so like this is why like I think end of life and like maybe the repurposing,
Mm,
re what's the word I'm looking for, like reinvigorating, is interesting. And
right.
yeah, so like and making that as efficient as possible. um I think that is a really intriguing problem, um but maybe just as exciting as about, as in compared to like new chemistries starting from the scratch and having a good building block, versus like how do you disassemble everything, right? It's like I think of it as an engineer, it's like, you could disassemble mechanical devices, fix it, put it back, and it's just as good as new. It's much more difficult to do that to chemical processes, and those are some of our problems I think about. It's like, how do we address that, right? We have this performance filter in here, could we effectively remove that one day, um, and I don't know, take it somewhere else? Like people do that in the tire industry for there's a lot of carbon black introduced into car tires, for example. That's why car tires are black, and that's also why they're durable. But recovering that takes a lot of money, and it economically, and it just doesn't make sense. But if someone did make that happen, like that would be really, really cool. And I think that same analogy applies to pretty much anything.
Right. Yeah, well, yeah, that's a good point. It's how do you reinvigorate or get back out the value that's still there? Because nothing, almost nothing is ever completely used up, right? There's
Mhm.
always, you use the tire till the tread's down to, the wear bar, and then you still have most of the tire. Like that's, you've only the
Yeah.
overall mass of the tire, right? You've only used, I guess it'd be like 10%, maybe probably more like 5 or 3%, because there's really not that much material. It's like the smallest amount of it. So now you have all that, the molecules, the atoms are fine. Like there's nothing
Mhm.
wrong with the compounds in it. It's just not enough form. So how do you re-extract or refurbish or reinvigorate
Mhm.
in some way? Which I think, yeah,
It's
that's an interesting place to be focusing on, because I agree, it's probably the worst area for us. Like we're really good at creating things that are new and shiny, and then
right.
we don't know what to do with it after we use it once. We're like, oh, well, it's not shiny anymore, so I
Yeah,
don't know.
it's a really hard problem, I find. Like even to the exact same example, right? Like there are retreading services to which, is exactly as the name implies, the tire gets retreaded. I think a lot of this actually applies to industrial vehicles. We probably don't do it. And tires
No,
gets recycled. There's like steel fibers and things like that that gets like recovered, and then
right.
like you're left with this black rubber. And we've actually bought like used car tire materials and mixed it in together with recycled plastic to make hardware for organization in the UK,
Oh,
to show
interesting.
it's like you could use it. But I think maybe like the longer kind of consequences, like we hope people don't throw this away in the municipal garbage, because
Right.
like it's got 50% fillers and a good chunk of rubber in it. It's supposed to help get people thinking about the story, but like
Right.
it's also teaching people how to an alternative way of using industrial waste. And so this is what we get a lot, is just people coming at us with a lot of weird things, and we try to think of chemistries or kind of areas of applications to which we could use the industrial waste. Perhaps one day having like an e-commerce platform where people get to trade waste, and truly like one man's treasure is another one's garbage. Or perhaps I said it wrong, it's the other way
Either
around.
way, it works out.
Yeah,
Yeah.
but
Oh, that's awesome. Well, this has been super great chatting with you and learning about this. Is there, for anybody that's really wanting to find out if their trash can be used in something and actually turned into a product, or who knows, maybe you can find somebody's industrial waste and another person and combine it, be the matchmaker, right, between you can't use it but we can, which is great. We need more of that. I think I think I gave the example of like, uh waste material from tequila making is used in sponges now, because it's just getting burned. So as we have a
Mhm.
lot, we have a lot of material that nobody is thinking in different industries, because they only use it for what they want, and they don't think of the other uses, which is what you guys are looking at. Well, you're you have all this stuff you're producing. It's actually useful, guys. We should use it over here and make something useful. So how do people get a hold of you in wanting to start that journey of making something useful?
I like to think we're generally a pretty easy group to get a hold of. They could visit us at carbonupcycling.com, where they could kind of hit contact us. And of course, I'm generally pretty easy to reach. It's just Peter at carbonupcycling.com. That's my email. Of course,
Fantastic.
if you wanted to check out anything else like our consumer product work, or possible other ways of using carbon, for example, our consumer facing website is expeditionair.today. And they could visit kind of sources from, for example, like the Carbon X Prize and the X Prize Foundation's website
Mm.
for some additional information about carbon utilization and other carbon to value initiatives.
Yeah, that I keep forgetting that Carbon X Prize is going on. I think for
It's still a
a few
thing.
more years. Is I think
Yeah.
it's a few years out before they'll pick anyone. So yeah,
Yeah, the Elon Musk one. Yeah.
it's a ways out there.
It is, but we're pretty keen to see what might be like, who are the semifinalists and the finalists of that
Right.
competition. I mean, having been through one, it it's probably quite interesting to actually watch from the sidelines and see if people have gotten better than us and kind of struggle a little bit less than the stuff that we went through.
Well, that would mean you're doing a good job, and technology is keeping on moving forward, which is good for everyone. So
Mhm.
perfect. Well, I really appreciate you taking time out of your day to be here with me and talk about what you guys are doing. And we'll make sure in the show notes, we'll have links for everything you just mentioned. That way people can easily get a hold of you guys. And yeah, any final thoughts before we wrap up?
Final thoughts? Did you know? Here's some facts, or well,
Let's do
not
it.
these are not facts, but these are numbers from literature. By 2050, there's going to be more plastics in the ocean than fish. I learned this on a webinar one time, and it's actually just bizarre. And I think it goes to show how perhaps humans and maybe the Homo sapien race in general has a tendency to overcorrect itself. How it's like
Yes.
paper, glass, plastic, and then here's CO2 again. So I think one day I'm sure there's other big problems that we'll try to tackle as a human race, and so keep your eyes peeled. I think there's always waste for anyone to pick up and turn it into a viable business. So I'll leave it off as that.
Well, that's perfect. That's perfect ending there. Thanks for being on. I appreciate it.
Awesome. Thank you, Ian.